can be solved. So the question says students are collecting data about the amount of water needed to fill different sized paper cones. Their measurements are compared to a calculated volume. And it gives you the formula for calculating a cone, and it tells you you're going to be using pi, the radius of the base of the cone, the height of the cone. And it tells you that a program and a subprogram have been started to carry out the calculation. So it's a very typical question 5 in which it's going to use a main program and a subprogram. And the next thing it says is amend the program and subprogram to meet the following requirements. And we're going to deal with these one at a time. The subprogram must work for any value of radius and height passed as parameters. You can assume that values passed to the subprogram will always be numbers. No validation is required. The subprogram must calculate the volume based on the input parameters. The main program must print the volume formatted to show 3 decimal places. And it gives an example of 16.135. So we're going to start from the top of the file and just have a look and see where our prompts are. So there's the first one. And it says import a library to use Pi. Well, I know that the library that Pi is in is the maths library. And if you're not sure, you can take that from your PLS. We've got some values which are hard-coded for testing. So cone height, base radius, and cone volume. We're going to worry about those a bit later on. And let's work on the subprogram first. So it must work for any value of radius and height passed as parameters. So it says add parameters inside the brackets. And at this point, you might be wondering, well, what do I call those parameters? I'm not sure what to call them. So have a look down through the code because they will always give you some prompts here, particularly in question 5. So what we need to do now is to work out what these parameters are. And as we can see down here, lines 22 to 23, those parameters seem to have been used in printing, so p radius and p height. So that must be the name of our parameters up here. And that's a very common thing in this exam, that if you look a little bit further down into the subprograms or look into the main program, you'll quite often find clues to help you. So I'm going to put p radius and p height into this. And there are my parameters done. Notice I've tidied it up a little bit just to make it a little bit clearer to see. The next thing I need to do is the calculation for the volume, and you can see the volume formula here. One thing to be a bit careful of is when you start typing in Python, just make sure that your tabbing is correct. If you started typing here, then that doesn't belong to that subprogram. So what you need to do is make sure that you've tabbed it in correctly. And one way to do that is to go to the previous line, hit the enter key, and that gets you tabbed in properly. So now what we need to do is complete the calculation for the volume. And again, it doesn't really tell us what the variable should be, but if I have a look further down, I can see that there is this line 29 which says print the volume is the volume. So what I can do perhaps is use that as my variable, and I am going to put 1 divided by 3 just to make sure that 1/3 part of the formula is correct. Notice I put it in brackets. Multiply that by math.pi. There's no brackets at the end of pi. It's a constant, so we don't need to use it as a function. I'm going to multiply that by the radius to the power of 2. And be a bit careful with this. I've just made a bit of an error. That should be p radius there. And I'm going to multiply that again by the height, which is p height. So there is my calculation done. Finally, on the subprogram, I need to return the volume to the caller. And I'm going to start by naming the variable that I want to. Finally, I need to return the volume to the caller. I'm going to make sure I'm in the right place. And I'm going to start with the return command. That makes it a function because functions return a value, whereas subpro procedures don't. We're going to return the volume. So that is our subprogram done. So now we can turn our attention to this bit here where it says call the subprogram, passing parameters, and catch the return value in the correct variable. Well, the word catch here simply means store the return value in the correct variable. So I need to store the volume. And if I look up here, I can see I've already got 3 global variables that I can use, one of which is cone volume. And that's the one I need because that's what I'm actually printing. And I can also tell that from later on, if I look at line 45, cone volume there is being used in the printing. So that must be the one that's storing my volume. I need to call the subprogram. In order to call it, I'm going to give it the name. Notice I'm using a little bit of copy and paste here just to make sure that I don't mess up any typing or make any typos. I now need to use the parameters. Well, the parameters are the radius and the height. So I've got the radius, and these have to go the right way around. So I need to start with the radius, and the next one I need to do is the height. And the reason that they go this way around is because that links to that parameter, and this variable links to that parameter. And we've covered this a little while ago, but these are known as the arguments, and those arguments pass data to the parameters, and they have to pass them in the right order. So that's why radius goes first, and then height, and height goes second. Finally, we need to print the total volume to 3 decimal places using string.format by completing the pattern inside these squiggly brackets. Now this is where you need to be careful. Python does not like having spaces in here, so I'm going to remove the spaces, and I'm going to put in the first thing, which is always a colon. And again, if you're not sure, take a look at the PLS and you'll see that's in there. Now what you're used to when you do string formatting is to tell it whether it's left aligned, right aligned, centered, and you're also used to telling it how many places you're going to store it in, so how many places you're going to display it in rather. So 10, 6, whatever it might be. Now actually, it doesn't say anything like that here. It just says format it to show 3 decimal places. And it also says it must work for any values of radius and height passed as parameters. So it could be that we end up with 116.135 rather than just 16.135. So we don't know exactly how many spaces we're going to need. So I'm actually going to remove these 2. And what I'm just going to do is focus on the 3 decimal places bit. And again, if you look at the PLS, it will tell you that to format something into a certain number of decimal places, you put a dot, give the number of decimal places you want, and because this is a float, I'm going to put the letter F here. I'm now going to run this, and here we go. It spits out the radius, so there's that bit. It spits out the height. It now does the calculation and prints it without any formatting, and then finally prints it out to 3 decimal places, so that matches what they've asked me to do over here, and that's the end of that question.